Alright, good morning, Algebra 2 kids, or students. Welcome. Sorry I'm not there today, thanks to the joyous ACT test. But for today, we'll still have to actually continue with the next section in our book, section 813. Hopefully by now you have this classwork sheet. We will be collecting this at the end of the hour, so make sure to have your name on it and to be filling it out kind of as we go, and I won't actually. So ultimately the way this will work, I will kind of work through a couple of the problems on here, so that way enough that you should be able to complete it on your own or with your groups. And yeah, and then we'll still turn it in, and the homework 54 through 62 will still be due tomorrow. So as we work through this, the way this is different from previously is so far in 811 and 812, we were looking at these graphs and coming to a point that we could write an equation with just looking at the graph, or we would be given the equation, be able to sketch the graph. The part that'll be different is today, when we do our sketches, we want to be able to focus on figuring out equations that will represent all of the points on the graph. So coming up with more of those specific equations. So far, a lot of the sketches that we did didn't even include the scale on the y-axis, because we were sitting there going, all we're going to focus on is the x-intercepts. But now we're going to say, hey, like here, for example, we have the sketch. How can I make sure that my equation will exactly go through, say, this point, -2, 8, or 1, -4, and 1, -4. So the idea of coming up with the exact equations, not just, here's one that gives me that general shape and goes to the right x-intercepts. So as I started talking about this first graph here, the idea that we can use our 3 x-intercepts of -3, so my roots, at -3, 0, and +2 to say, all right, so from what we did before, that means I'm going to have 3 factors. X plus 3, 1 -3 will make that 0. X minus 2, and I'm going to erase this part and throw the x out front. X. So I know that this equation will give me the correct shape, and if I pull out my calculator and try typing this in, x times x plus 3 times x minus 2, I hit graph and start comparing, and the light is not being generous on this. Let's maybe switch my window so it matches what we have on our scale. X is -4 to 4. The y's, I'll go -8 to 8. Maybe I should do 9. Alright, so it looks like it could very well be super similar. But let's double check. For example, we are told here goes to the -2, 8. So if I go second table, okay, -2, 8, 1, -4. So it matches. We're happy, it works. So if we double check with part B, then the same idea. My 3 roots, again I have 0. Again I have the -3 and 2. Only the one slight difference here. X plus 3, x minus 2. Is this 0 root. Well, notice it's flattening out and then going back up again. So this is part of what we were talking about, tried to talk about yesterday. Where we ran short on time, but with the idea of a double or triple root. If I look at the shape of the graph as it goes through the graph, it's coming up, leveling off, and then continuing back up, just like the x cubed graph does. That means it's going to be a triple root. So that part, the factor that gives me the root as 0, so in this case just x, will be an x to the third equation. The other big piece that we see from this graph is that as we go off to the right, as x keeps going up, my equation is going down. That tells me that the whole graph is going to be negative. It has a negative orientation, so I need a negative out front. So if I double check this in my calculator then, negative, and second insert to the third power, otherwise it's the same equation, negative x cubed times x plus 3 times x minus 2. That's a much better spot for seeing it. And my scale doesn't match at all, but we see it looks like it has that same general shape, but let's double check a couple of the points. Negative 1, let's see, if 2 tick marks is 10, that should be negative 5. That's the second table. Negative 1, negative 6, that could be right actually. Negative 2 is right around negative 30, seems reasonable. Positive 1 just below 5, okay. So this also looks to fit. Alright, I have my 2 roots, negative 2, so an x plus 2 term. But again, the idea is this one's not going through, it's coming up and bouncing off. So right around there, that looks like a parabola. It's going to be a double root, x plus 2 squared. And then we have our root at positive 1, so an x minus 1. Let's graph it just to double check. X plus 2 quantity squared times x minus 1. Oh, I forgot one piece. As we go off to the right, it's going down. I can see even as I look at my calculator, hey, what I typed in is upside down compared to what I see on the screen or on the page. So I should make it negative. Second insert, negative. There we go. All right, here's where we start seeing a little bit of an issue though. 1, 2, 3, 4. 2, 4, 8. My y-intercepts do not match. This one has a vertical stretch to it. We have otherwise not been accounting for. That idea that these two graphs still have the same general shape, but this equation does not give us that exact shape. So it's not quite accurate because there's a vertical stretch. I mean, it's this idea of just like with 46 here, we're going to be multiplying, whoops, there we go. We're going to be multiplying by something out front to do that, to give it a stretch factor. A vertical stretch. I should probably make sure to write more legible. So it's this idea that to be able to find this exact equation, I can use that point, like if I do this as y equals a, x plus 2 squared x minus 1. So if I still focus on my x-intercepts, kind of like what we did when we were finding the exact equations of a parabola, I can take this point that we know, 0, 8, and plug it back in. 8 equals a times 0 plus 2 squared times 0 minus 1. 8 equals a times 4, 0 plus 2 is 2, squared is 4, times negative 1. 4 times negative 1 is negative 4. Divide, I get negative 2 equals a value. So my actual equation should have been, erase this and rewrite it so it's nice, negative 2 times x plus 2 squared times x minus 1. Again, that idea that there's a stretch factor. So really that's what we're going to keep working on throughout, is this idea that Melvin's writing this equation, but we'll find there's a stretch factor. So if we know it goes through the point 1, 16, I can set this up. 16 equals a times 1 plus 3 times 1 plus 1, 1 minus 2 squared, and finish solving for that a value. Beyond that, it's just doing more practice with this. 48, this graph might look familiar. In 1.1, when we were looking at the Math America Land Carnival Company's roller coaster, this is that same graph. The difference is they gave us a y-axis now. So instead of finding, oh, here's an equation to give us that general shape, they decided at, what was it, 20 feet, this 2.5 value, that it should be at, or 250 feet, so this 2.5 value on the x, we should be 20 feet below the surface, so negative 0.2. They gave us an ordered pair to be able to find the exact equation. And then there's just more practice with doing just that. So if you have questions, feel free to email me, but I won't be able to get back to you till after lunch. Otherwise, feel free to stop by after school, before school tomorrow. Generally, I'd say during lunch, but again, I won't be here during your lunch today, most likely. But yeah, otherwise, I've emailed this video, link to this video to you, and good luck. Khan Academy, I'm sure, has things on this, or general Google search. I'm sure you can find other pieces to help if needed. Thanks. Have a great day.